n over 18 an integer? The answer of the question needs to be given in the form of either yes or no. Now, see, n over 18 will be an integer only if n is divisible by 18. So when we look at the first statement, we realize that 5n over 18 is an integer. And hence, we also realize that there is no common factor between 5 and 18. So people start thinking, okay, 5 has no relevance with 18. So for this to be an integer, n must be divisible by 18. Which is absolutely fine to start with. But the major problem here that most of the students face is they start having certain assumptions. Now, the assumption that's going in the head of those students who think this is sufficient is that n cannot be in fractions. Or maybe they are not even thinking about it. They are conveniently thinking only the integer values which are possible for the value of n. Whereas, ideally, because like I've been saying that in data sufficiency, if you don't want to be tricked, then your intention should be to prove that the statement is not sufficient. So let's take this information on face value and analyze. How do we do that? 5n over 18 is an integer. What are the integers? Some examples, if we have to take, maybe 1, 2, 3, 4, 5, 6, etc. Which means that n may be either 18 by 5, if 5n over 18 is 1, or 36 over 5, or 54 over 5, or 72 over 5, or 18. So now when you have done this much exercise, I think you have sufficient reason to understand where you were going wrong. 18 is an integer which is divisible by 18, for which n over 18 will be an integer, giving an answer as yes to the question. Whereas all other values will give answer no. And therefore, the first statement is not sufficient. So I reiterate the most important strategy of the data sufficiency, which is always try to prove that the given statement is not sufficient. Now, out of the 5 options of data sufficiency that we have, option A and option D can be eliminated because the first statement is not sufficient. So obviously each statement alone cannot be sufficient. With a similar intent, now let's look at the second statement, which says 3n over 18 is an integer, which means 3 can cancel out 18 6 times, which also gives us that n over 6 is an integer. And the integer values may be 1, 2, 3, 4, etc. once again. So n becomes either 6 or 12 or 18 or likewise. Once again, we have the answer in the form of sometimes no and sometimes yes, because some values of n are divisible by 18 and some are not. Therefore, the second statement is again not sufficient, which also eliminates option B. But the very important fact that we should gather from this exercise is that the first statement was not sufficient because there were some possible values of n which were not integers. Whereas second statement is going to reject all those possible values because second statement clearly tells us that n has to be an integer multiple of 6. If 6 goes the other side and gets multiplied with an integer, n is going to be an integer multiple of 6. So these kind of observations are very helpful when we combine the two statements. So when we combine the two statements, we understand that the only common values that now we are left with are the values like 18. The next such similar value will be 36. And the next value will be 54, etc. And the good thing about all these values is they are all divisible by 18, giving answer yes to the question. Therefore, together the statements are sufficient and the answer of the question will be option C.